I want to show an experimental product that is not currently in AWIPS but has been demonstrated at the Satellite Proving Ground Hazardous Weather Testbed and received favorable reviews. Therefore, we view this as a potential operational product in the future. You're looking at the Octane Speed Sandwich product. This is a blended imagery product which combines cloud-top wind speeds computed from an optical flow algorithm with textures from visible imagery during the daytime and IR at night. Cloud-top wind speeds are calculated from 1-minute GOES mesoscale sectors. See the Resources tab in the upper right for links to real-time data available on the Cirrus Slider website, along with additional information on the product. On the Slider website, look for Octane Speed Sandwich after selecting one of the mesoscale sectors to view the data. For our case, see the legend in the upper left, which shows the colors corresponding to cloud-top wind speeds in knots. I'm going to stop the loop, and what we want to do is focus on the region where the clouds emerge associated with the Stingjet. Recall in the derived motions winds data we looked at earlier, we had no wind observations over that region. However, with the Octane Speed Sandwich product, we do get observations. The red colors at the leading edge of the Stingjet near the end of the animation correspond to wind speeds of 45 to 50 knots. Keep in mind these are winds at cloud top, not at the surface. The winds are likely stronger within the Stingjet. The key would be getting precipitation within these shallow convective cells to produce downdrafts and allow the very strong winds at low levels to the surface. Now let's focus on the wind speeds from the perspective of the radar and the two buoys that are available in the marine zone of interest in and slightly west of Monterey Bay. The buoys are labeled 46092 and 46042 so that you can compare them with other data sets. Here I've added wind observations from the buoys just above the label and colored yellow. Buoy 46042 reports every 10 minutes and provides sustained wind speed along with wind gust. I plotted both of these values in knots just above the buoy label. Buoy 46092 reports every hour with observations at 17 minutes past the top of the hour. Buoy 46042 appears to be slightly northwest of the highest wind speeds observed in the velocity data, perhaps being just northwest of the Stingjet. Maximum sustained winds at that buoy were 27 knots and with gusts to 36 knots, all before the arrival of the Stingjet as seen from the velocity data. Buoy 46092 is of limited value because of the temporal resolution of the data being hourly. We observed sustained winds of 28 knots with the 1917 UTC observation, which appears to be before the arrival of the Stingjet. The next observation would not be available until 2017 UTC, likely after the Stingjet passes by. As for the velocity data, we're confident that the Stingjet is being observed based on what we've seen in satellite imagery and products, and is confirmed as a localized region of very intense winds at low levels in the velocity data. At 18Z, I'm going to stop our loop and just tell you some of the wind speeds that were being observed. At this time, max winds were around 64 knots, being observed at 11,000 feet AGL. And if we move forward to 19Z, across this region, max winds were around 75 knots at 7,500 feet AGL. And then by the time we get to 1918 UTC, we're dealing with velocity de-aliasing issues, but outside of that region, we still observe winds over 70 knots. Finally, the VAD wind profile at the KMUX radar shows the trend of increasing wind speeds at low levels with values in the 40 to 50 knot range.